Awesome. Okay. So again, if you guys don't want to be in the recording, feel free to turn your camera off. You guys do not have to turn it on. But continuing on, this is the iris.csv dataset. We will be using this right now. For some reason, I could not just drop it in as a .csv file in the chat. So you can just go onto Kaggle, download it, really easy. Let us know if you run into any problems. Again, it's a really popular data set. You probably have worked with it before. We will go into all of the features that are there, and I will explain everything. If you guys haven't already, please sign in. And if you guys don't have the sign-in sheet, our associates will be happy to provide it to you in the chat. So just feel free to ask. And if you guys do want to follow along, I'm also going to send this in the chat right now. This is in the Baruch AIS GitHub. This is going to be the workshop that we're going to be following along to. It has all the code written out for you, and I'm just going to be going through it and describing why I did that and what is it. So let me just send that into the chat. And all you guys have to do if you do want to follow along is just click open and collab. That's it. Simple, easy. Let us know if you guys run into any issues with this. So I'm just going to give a minute for everyone to do it. Okay. So again, you guys already have this downloaded, the iris.csv file. So for this IDE, Google Code Laboratory is really easy. It's nothing like if you guys have ever used VS Code or Anaconda, usually you have to do a path to this right here, and I will explain what that is. This just lets us know where that file is. In here, it's really easy. You don't have to do it. All you have to do is click this, and basically all your files are going to pop up, and you can just search up on the side iris.csv. I don't think you guys can see my files, which is okay, but something should pop up. All you have to do, type in the search bar is iris.csv and click that, and that should download that into your files right here. So it should look like this. So you have this one. And if someone can give me a thumbs up to let me know that they did that, if you guys are following along. Or just let me know in the chat if you guys have that down. Okay, I'm gonna move on. Okay, so welcome to the workshop, everyone. So again, this is cleaning and visualizing data with Baruch AIS, woohoo, with the data science team. So just to get started, if you guys have never used Python, that's perfectly okay. We will describe everything that we're using. If you have but haven't used Pandas or Numpy, these two links go straight into the documentation for Pandas. So if you guys want to check out what kind of library this is, basically, if for all those that don't know what a library is, basically it just has all of the functions so that you don't have to create it because it's not already in this IDE. It's already not in Python when you're using it. So you have to import a library in if you want to use the functions that it has. So all these websites show is what is it? What are the functions? What are the parameters that they use, etc. And you can get that all in these two links. It's very helpful if you want to figure out what it has, what you can do with the libraries. It's really cool. And basically all libraries have something where they explain what all the functions do. But feel free to check it out. It's just some extra resources for you guys. But let's get into the main portion of the workshop. So what is dirty data? Basically, it's data that's inconsistent, inaccurate, or incomplete. Basically, null values that just don't match up with the minimum value, with the median value. Data that's not accurate, data that has nothing to do with what the data set is about, or data that just has no reason to be there. Basically, if you are running a machine learning model, you want that data to be accurate, right? Otherwise, you're going to get weird, even though your machine learning model is going to be accurate, when you're going to get it, let's say you get an accuracy score of let's say 98%. But then you try to run that same model on a different type of data set, and it's saying that, oh, it's 78% accurate. Why is that? Because it's not running on accurate information. Garbage data. Yeah, perfect. You guys said it perfectly. So how can we fix this? Basically, we're going to do something called exploratory data analysis, for short EDA. It's really easy to do, but basically all you're doing is we're trying to understand our data set, and we're going to try to find patterns within it. So in order to get started, we're going to import some libraries. The first two that I introduced to you guys were Pandas and Numpy. If you guys have never used this before, Pandas is just like a data analysis library. It helps us, for example, load in a data set, check out a data set, etc. And we're going to import that as PD, which is just standard practice. Numpy is all that stands for is numerical Python. Where we're working with data, we're going to be working with numbers. That is why we import it, and we're going to import that as NP. These two, Matplotlib is for plotting, for visualization. Same with Seaborn. And again, this is standard practice to import it as this. And it's just, let me show you really quick. For example, you see how, let me show you. Well, we can do the first one. Right now we do PD. Instead of writing out pandas every time, we just do a quick PD. But yeah, so we're gonna run that. And now the first step that we wanna do is load in our data set. So right now we're gonna call this function. So let's comment this out. So when you first load in this function, nothing's gonna pop up. That's how it's supposed to be. Basically, it's just loading in that data into your notebook. And so the way we would do it is PD, so we're calling in pandas, so we can use this function, read.csv. Read.csv, all it does is reads every single line from that data set. So because we have a CSV file, we're doing _CSV. But let's say you have an Excel file, you can do it for Excel as well. I think it's going to be read_Excel. Again, if let's say we don't know how to read in an Excel file, you can go to pandas and find that. But we are going to save this to a data frame, which we're going to label as DF. Again, standard practice, just especially if you're only working with one data set. Eventually, when you get more advanced, you're going to have, let's say, a training and testing data set. But right now, we're just going to label it as DF. Easy to remember. We know what it is. Only one data frame. And this is a path. This basically lets us know where our file is. So our file is in the content, which is over here. And then we want the iris.csv dataset. So this is why this is all it is. If you are using a different IDE, you can get a path from Mac. All you would have to do is when you download that data set and you click on that file, you can, if you're on Mac, I'm not sure how to do this on Windows, you can hold down options, right click, and if you scroll down, it should be copy path name. That's a little hint or a trick that you guys can use, which is it's really easy to path that way, so you don't have to go searching. If not, on Mac, there's also an option where you can see on the bottom what that path is, and you can copy it from there and like use the slashes, use the formatting. But there's an easy way for that. So right now, what we're going to want to do next is we're going to check the first 10 values. Before we ever do anything, we want to understand what is our data set about. What do we have in the data set? Let's say I've never seen iris.csv before. So the first thing I'm going to do is I'm going to check it out. Let's see what we have in there. So we want to use our data frame. We're going to do df.head with the first 10 values. .head gives us the first 10 rows, gives us the first rows, but 10 is what signifies, okay, I want 10 rows. Let's say here, I get 10 rows. Let's say I don't want 10 rows. Let's say I want 5 rows, right? This amount just sets how many rows that they show. And for anyone that's never used Python before, again, perfectly okay. We start our index at 0. So usually, like for some people, like, I know you're used to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but here we start from 0, and that's why it ends at 9. But okay, looking at our data set, okay, I can see that we have 1, 2, 3, 4, 5 features. Or columns, whatever you'd like to call them. Usually we call them features. But looking like, okay, this is cool. It doesn't tell me much, but at least I can see our data set. Another thing that we can do is we can also look at the last 10 values or n values, whatever you guys want to look at. But we will look at the last 10 values just to see. Here we notice something like off, which you might not always see it if you have a really large data set. But over here we can see like, oh, interesting, like we have null values. That's nan is null. It means there's no value, like no value inputted there. It could be that somebody input it wrong, somebody maybe forgot that row, or thought they were going to come back to it. Whatever the case is, this row is null for these 4 features. Just checking the chat. But yeah. Also, if you guys want to see the shape of the data, all that this signifies is 154 is the amount of rows that we have, the amount of like observations that we have. And then 5 signifies how many columns we have, how many features we have. We have 5 features. And so with this, I will show you like moving on. But with this, we can sometimes see, okay, like let's say I drop a row, right? We can see like, okay, it went from 154. Like I know we have 154 rows. I drop a value and then it shows 153. I can confirm that it accurately dropped 1 row, like it accurately dropped something. But I will show you that later. This is just as a heads up. Just so you guys know, if you do this, does anyone want to take a guess? Do you think it's going to work if I run it like this? Yeah, no, it's not going to run. So yeah, exactly. Perfect, Tifaz. It's not a method. You're going to get an error. Usually you can figure out like you kind of going along, you kind of have to figure out like what you need for this, what you don't. Especially like when you're just starting, it'll eventually catch along. But for dot shape, you can't use the oh my god, I'm already blanking what these are, but you can't use these. You can't use these ones. So we just call it like that. But now I want to see what columns we have. So even though we can see it in when we call like 10 values, the last 10 values or the first values, I can see all the features. But let's say you have a lot of features. Let's say I have like 100 features. Sometimes what your IDE will do is it will show like 3 dots which means it's like there's more in between and you won't be able to see everything. So I know that there are 5 features, but let's say I had 100 features. Okay, I know 100 features, but what are those features? What we can do is we can do list df columns and see it in a list to see all the columns that we have. So you can also take this out and it also run like this. Doing lists is just prettier. So that's why I like to do it. You can do it either or, but this again is just going to show all the features that we have. And okay, now I want to know, I want to know some more information about the data. For example, like what is the minimum value? What is the mean? How many values do we have per each one? Again, and so what we do is do df.describe. And this is going to show like all the statistical, there are more parameters where you can specify what statistical like means you want to go about it. Like, let's say I want to add like median, I could go ahead and do that and add that in, but just for the sake of this workshop, we're just going to do all of the default values, which is going to be count, mean, standard deviation, minimum, maximum, and then like 25% of values, 50%. If you guys know IQR, interquartile range, that's what this is basically. Like 25% of the values, what are 50% of the values, about 75, like etc. Again, you can specify it. I'm just going to use the default values for now, but you can specify which ones you want to like add on if you ever want to do that. But looking at our data set, looking at our statistical like overview of the specific data set, we can see like, oh, okay, like we have 153 values for each column. Okay, we have a mean of 6.8 for sepal length. Okay, but what is sepal length? Like, does anyone have like any clue what sepal length? Like, let's say you've never used this. Yeah, like we don't know it. If you have no clue what this feature is, your best friend is Google. So let's say like, again, I had no idea what is sepal length. So like you can search it up and I'm looking and I'm like, okay, like reading. So sepal is basically this part. I mean, like, again, I'm not a flower expert, but this goes to show again, like we saw 3 classes of different types of flowers, iris, the specific flower, but here it's showing that this is the sepal right over here, and then the petal is the whole entire thing. So yeah, you can read and see like what it is. Like again, most of us know what petal is. But yeah, so sepal I'm gonna assume is like this part, the lines. But let's say I still have no idea. Again, you can just search it up. You can also, honestly, you can look at some images to see like what is it. Yeah, so it gives a breakdown of everything. Google is my best friend. I want to say that. It's gonna become your best friend, especially when you're working like with data sets you've never heard of. Let's say I'm like working with cars and I have zero clue about like what motors are. Google it. But yeah. So yeah. Continuing to look at this data, I'm looking. I get up to maximum, right? Do you guys think like, oh, do you think everything is good with this? Like, does it look correct or do you think something is off? Like, can anyone tell me something that's wrong? Like looking at this.
The maxes.
Yeah, perfect, Andrew. The max is really off. Like, look at the mean. The mean is 6.8. Our minimum value lies at about 4.3, which makes sense. But 59 is really far from 6.8. Yeah, Daler, it's an outlier. Like, this is really odd. Like, 59 compared to like singular digits, like something's off. We're gonna look into this a bit more, but like we know like something is off with our data set and we have to do some more like EDA with it. But keep this in mind. Yeah, another way, by the way, if you guys do want to see like more about the data frame, is you can do df.info. And so again, it's going to show like all the features. So sepal length, width, yada yada. This is going to show how many values we have. This is going to show if we have like non-null. This is odd in the sense that we know we have a null value. So over up here, we saw like, oh, we have a null value. So it's kind of odd why this is here, but sometimes it'll like usually say it. And over here we can see the data type. So sometimes when you're creating machine learning like model, it's easier to work with numerical values. So if you see like an object, for example, you're going to be like, okay, let me see if I can create this into numerical value. We will have a whole entire workshop on doing one specific machine learning model, which we will make an announcement about that. But for now, like this is not important, but later moving forward, like it's important to understand what kind of data types we have for each feature. And so let's get started with the actual cleaning. Now that we have like an idea of what our data is about, like, okay, I know that we have 5 columns. I know we have 154, like 154 rows. There seems to be a null value, like outlier. Like there's so many things we have to fix. Like, oh my God, where do I get started? First step we're gonna do is we're gonna check for duplicates. We don't want duplicates. Does anyone know why we don't want duplicates? I think I've mentioned before. It's okay. In terms of accuracy, if we have a repeat value, it's gonna train or test on that value again. And we don't want that. Like we want it to be like, we don't want that. We just don't want it. So what we're gonna do is we're gonna do df.duplicated to check to see if there are any duplicate values. But as I run it, you guys can see like these 3 dots, which I mentioned before. How am I supposed to see all the values? Like this is not convenient to see if I have duplicate values. It's nice that the last 2 values are true, but let's say, for example, like what if there are more in between that we don't know about? So do you guys have like any idea what else we might do? How else we might change it? Or do you guys have any like ideas on how would we want to see this? Like in what different format would we might want to see this? Yeah, it'd be nice to have one number. So the way we would do that is we would do df.duplicated like we called before, which gives us the duplicated values. But instead of doing it row by row by row by row, checking each single like row if there are any duplicated values, we can just do df.duplicated.sum. And now we see there are 5 duplicate rows. From here, we could only see 2 of them, right? But again, there's like a bunch of rows over here that we don't, a bunch of observations that we don't see in this view. So we can just do df.duplicated.sum, and we see that there are 5 rows. Now, I'm gonna drop these rows. So what we're gonna do is we're gonna do df.drop duplicates, and we're gonna save that into a new data frame. And now I'm gonna check if these rows have actually been removed. So yeah, all of them removed. Okay, we checked that we have all the duplicates removed. That part is done. You can also see like unique values to see duplicates. But this method is better, but this is just an extra one if you guys do want to do it. So now that we have all our duplicates removed, our next step is going to be to remove the null values. So the way we're going to do this is df.isNull to see all the null values. But again, what do you think I'm going to say again? We're going to do dot sum again. I cannot see this. Again, the 3 dots. I cannot see all the observations. So again, just like before, we're going to do dot sum. And so here we see, okay, there is one observation in 4 out of the 5 features that have a null value. Before we looked at our data, we were seeing that, okay, like you could see that there was a null value, but let's say it was like in the middle and we couldn't see it. Now we know, okay, we have a row or multiple rows that are null. So we can also check for change in shape, like before and after, to see if it actually removes the rows after we drop the values. So we're going to do df.drop_na, sorry, df.drop_na, and save this into the new data frame. And now let's check if it actually changed the shape. Perfect. We know that it dropped 140. It dropped 1 row. So as we saw before, it was only 1 row that had all the null values. And so it dropped that 1 row. So again, you just want to do the sanity check just to make sure that this worked, because you get no output from this. So you might not see that, like, oh, did it work or did it not? It's just a sanity check to make sure like everything is good. And you can double check this way either. It's whatever method you prefer doing. Up to you. I just want you guys to know, like, there's 2 ways to do it. You can choose which one is best for you. Okay. But let's say we don't want to drop a feature, or we don't want to drop a row. What else could we do to fill that? Do you guys have any idea what we could do if we don't want to drop it? At least for numerical values. Yeah, perfect. Thank you, Afaz. Yeah, so Caesar, what we were doing to delete them is you're just dropping them. So like instead, if I don't want to use them, I can just drop it. Yeah, perfect, Amber. We're gonna replace the values. So okay, checking. We're gonna check again, like to see unique values. Again, it's just like good practice just to make sure. But okay. If you do not want to drop a row, for example, like let's say you have a situation where you just do not have enough rows, that even if you just drop 1, it's going to be detrimental to that machine learning model that you are trying to train this data set on. Like you cannot, by any certain means, can you not drop this. You can just do df.fillNA, and you can fill it, for example, with the mean, like we saw before. Sorry, I'm just gonna scroll up. You can, for example, like fill it with the mean, with the median, like whatever value, usually with the mean or median. Those are like the 2 standard ones you can fill it with. But yeah, so like again, if you do not want to drop the row, you can just fill it in with the mean or the median. It's more of a, when you're looking at like each case-to-case basis, what would work best. You just have to go and see. I can't like tell you specifically exactly what to use, but usually it's mean and median. Okay, I'm gonna really quickly just stop and see if anyone has any questions. Yeah, you can also replace with 0. Sometimes that might like cause an issue again because it's a null value. Um, you can, um, but it's not like the standard practice to do. Just because like if you're running it and the model sees like 000, it just means it doesn't exist. And you can just it just makes more sense to delete it. Yeah, normalization and standardization we can do after. Oh, it seems like the CSV file in Kaggle is different. Uh, is anyone else running into that issue? Okay. Oh, okay. You guys should have said something before. Oh my god. Yeah, I am going to 1 second. Yes, there's gonna be a recording, so you'll be able to rewatch it after. I am so sorry about that, guys. Okay, I'm gonna download it again. I was just having some issues in sending it in the chat. Okay. Let me know if you guys can access this one. Instead of iris comma 1, if you could rename that when you download it, and it should just be iris.csv, just so when you're like importing it, it doesn't get confused. Or you can do iris like file that I just said, you can add it onto this path. Please let me know if you can access it now. I'm so sorry about that. Yeah, I was having some issues earlier about importing, like for sending this for the sending in the data set for some reason, just it wouldn't send. Um, Now it seems to be working. But Sumian or William, if you could let me know, works. Awesome, perfect. Okay, you guys, just rerun the cells, like again, and see if it works. I'm just gonna rerun mine as well. Thank you, Faz. Thank you, everyone, for letting me know. I'm so sorry about that. But perfect. Okay. Yes, awesome. Thank you, Caesar. Yeah, no, don't worry. Like this video will be recorded. You guys can always reference it. Um, as I was saying earlier, like this is basically the precursor if you guys are interested in machine learning. It's basically what you have to do before creating a model, just so you can like confidently say like this data is clean, this data is ready to be used. So I'm just like giving the breakdown on how we can do everything. But yeah, okay, I'm gonna move on if nobody has any other questions. But yeah, awesome. Yes, as I was saying before, like if you have numerical like data and you can yeah, you can have the option of filling it with 0, but you can again you can run into some errors with that. It just again depends on a case by case basis. Uh Preferably mean or median is what you would use, or any other like statistical measure depending on that. I'm gonna repeat it for like the 10th time, but like mean or median is what I would use. Um But let's say I have a categorical variable. Um, you can replace it with a space or the quotation marks. Um, Quotation mark, space, quotation mark, not like the actual word. But or anything you want. Usually it's a little bit more difficult with categorical variables. Usually I would end up dropping those, but you can I can do some more like explanation on this later on if you guys would like. Um, But yeah, that is another way that you can do it for the categorical values or for like the string values. But now I want to check if, again, like if there were any structural errors in our data set. So I'm gonna check to see the unique values like we did before, df.n unique. And I can see already that there are no structural errors. Can anyone tell me, can anyone take a guess on as to how I know this? I will give you guys a hint as to how I know this. And this has to reference what we were doing previously. What we were doing earlier, sorry. Take a look over here. How do I know that we have no structural errors? That there is nothing wrong with our categorical variables for this specific data set. Can you guys can hear me? Okay. Yeah, structural errors, it's like categorical errors. Sorry, not categorical. Errors that happen in okay. So looking at this specific one, because I checked all our numerical ones, right? But we didn't check the last one. We didn't check class. Structural errors are basically errors within objects, within the string features, the object features. How do I know that there's nothing wrong with our class feature? Hopefully that clarified. Okay. I know that there's no structural errors because when dealing with structural errors, all I want to do is look at class because that is our only object feature. There's nothing wrong with it because I already know that there's only 3 kinds of classes. As we saw before, as I was let's say as you were researching your data set, as I was researching the iris data set, there's only 3 classes. There's only versicolor, setosa, and virginica. Hopefully I said that right. There's only 3 kinds of flower species. So I know in our data set, just by looking at all our values, that at our unique values, that there are only 3 kinds of classes. So I know that there's no structural errors, that everything is good in terms of the class. Yeah, so if we do, for example, have a structural error, let's say we got classes 4. Like that, let's say you would say, that is weird, there's only supposed to be 3 classes. I would go and see what that row is that has the 4th class. What is that 4th class? And yeah, you can fix it by just checking that row and using fill NA to change that value or to remove that row. And so now our final step is to double check. Let me just continue running all our cells. Now our final step is to double check, did we fix these outliers? Is the statistics going to change now that we've removed them? Okay, this is our first statistic that we had. That is really odd. But still appear the class. Caesar, what do you mean by this? Oh yeah, but now we would again double check for the outliers to see if everything was fixed. Did you filter the class object? Oh no, I didn't. So for the class, I already checked by just looking at unique that we didn't like, there was nothing wrong with it. Hopefully I'm understanding what you're asking. But there's nothing wrong with it. I wouldn't have to like do anything with it because I already know that we have 3 values. Hopefully that answered it. But yeah. Yeah, you like let's say we did have 4, you can again you can do some code. You can say like, okay, like for example, let's say I want to look at the unique values. We're gonna do df.unique and look at a specific row. I can later on after this recording, I can show you how to do that if you would like. But I can show you how to do that later. Like let's say like I added a row, like I will show that how to do that later. That is a good question though, thank you. Okay, now let us check for our like for the rest of the outliers. Like, do you guys still see anything weird with it? Yeah. Yeah, like the min and max, like the max is still weird. Like, why do we have 59 when our mean is only 6? And all our looking at like 50% of the values, there's only 5. Like, okay, what is going on? Why is this 59? And count. Count is fine. Maybe there are huge flowers, yeah, who knows? Yeah, the count is actually fine, and I will show you why. Because we were dropping a lot, we dropped rows. So even though our original like count was 154, because we dropped these 5 rows and then another one, so we dropped a total of 6 rows, it's gonna be 148 rows. So that's why count is 148. So it's just saying that there's 148 rows for sepal length with petal length, petal width. And so continuing, like these huge flowers, like, that is interesting. Let's do some visualizations to see like in comparison to the rest of our observations, where do these like huge flowers sit? So we can do this by making a box plot. We're going to use the Seaborn library, which is SNS, that we labeled earlier, right here. Import Seaborn as SNS. And so we're going to create a box plot. So it's going to be sns.boxplot, and we're looking at our specific data frame. So looking at this, something looks off. Also, yeah, they are definitely outliers. But yeah, let's say like I didn't want to do a box plot. Maybe let's say I want to do a histogram. Like let's say I have no clue, like should I do a box plot? Should I do a histogram? So okay, let's say I have zero clue on how to create a histogram in the Seaborn library. Google best friend. What is the definition for Seaborn? This is so right about my atrocious spelling. Okay, Seaborn histograms are made using the his plot. So let's change that. Let's see. Yeah, and ignore my spelling. From this, we can see like, can I understand this? Absolutely not. This is just a mess. Like I have no clue what this means. So that's why I chose box plot. There are more statistical ways to explain this, but just looking at visually, like I have no clue what this means. So that's why I went with the box plot, just in case anyone was wondering. Just because it's easier to see and also makes box plot for each individual feature. So I can see like, are there outliers for each single feature that we have? And obviously, as you can see, the huge flowers are the outliers. And you can adjust these axes, I don't know how to say that word. Again, in the parameters, I'm just not gonna mention it here, because I'm throwing a lot of information at you. I don't want you guys to get overwhelmed. But if you did want to change like the axes or the color of the box plots, you can modify it as you wish. Yeah, you can modify the axes if you want. There should be like a parameter with the changing the axes. I'm just not going to show it here again because I'm throwing a lot at you, but there is a way to do it. Yeah. And you can also change the color. There's a lot you can do with it. I would recommend like searching up like Seaborn library. Again, ignore the spelling. And it like breaks everything down for you here. Like, yeah. It's like D3 in JavaScript. Honestly, I'm not familiar with JavaScript. I can search that up, Caesar, if you want afterwards. I'm not familiar with JavaScript. Okay, yeah. But yeah, like as I said, like these dots are indicating that we do have the outliers. So I don't want them. Like I don't want our data to be messed up by these outliers. Like you can see that this is a normal range for our values to fall. So I want to remove them. I like changing them. I don't want them. Like how I don't like changing them wouldn't make sense just because like there's no values. I just want to remove it. I can remove it, so I'm gonna remove it. So the way we would do this is we would find the specific row in which the values are. So this is why I created a box plot so I can see, okay, like visually, where are these outliers? So let's say, for example, for sepal length, like I'm looking, okay. So for 10, okay, 10 is like still a good range. 20, there are still no values, but let's say I'm gonna take 20 as the margin, and anything above 20 is gonna be considered an outlier. The way you would write that is I'm gonna create a condition, okay? I'm gonna say that for the data frame, for specifically sepal length, for df sepal length, for this just individual feature, if it is greater than 20, that's it. That is all I want in this condition. I just want to know which row is greater than 20. That is all that this condition is saying. And I want to print this condition in relation to our data frame. So running it, we get that row 51, we see that the outlier 59. Right? Like we can see, okay, I finally found where the outlier is. Now I want to remove it. I don't want this messing up our data. So I want to drop it. So we are going to drop this row like we did before, except instead of like drop in A, we're just going to do dot drop. And oh, yeah. Oh my God, I forgot. If you hover over, for example, like the specific, it shows you all the parameters you can do. So yeah, again, you can see all the parameters. These are all the default parameters though. But yeah, or most of the parameters it'll show. But I want to drop this specific row. I want to drop row 151. So df, I'm going to do df.drop row 51. And just so you guys know, we had 148 rows, but the index on this specific one was 151. Like, so, okay, wait, this can get a bit confusing. Let me just explain. So these already had preset like indices. Like if you were looking at this one, the ID is one like this. And so that's why it's 151. It's not that there's like 151 like 151 observations. It's just that is the indice that it was at. So, but there's like 148 values total, 148 observations total. But yeah. And so we drop this row. Does anyone want to guess why I got this error? It might not be that obvious, but does anyone want to guess why I just got this error? Here, let me show you this. Yeah, there's 148. It's just 151 is for this specific row. No, it's not because the index starts at 0. Oh, wait. No, but you guys have really good guesses. I already ran the cell before. I already dropped this row. This row doesn't exist. So if I try to keep rerunning it and rerunning it, it's not going to be found because I already dropped it. So it doesn't exist anymore. So if you ever do run into this error where it's like, oh, it's not found again, but you just had it, like you just saw it, it's because you probably ran it like more than one time and it already dropped that row. But it's already dropped, and the way that I can check that is bada bing, bada boom, running the box plot again, and as you can see, no outliers. Now, in terms of the sepal width, sorry, you can see that there are still like some values that are out of the sorry, I got confused. Sorry, just one second. Thank you for. But yeah, so you can see like with the sepal width, like we have some values that are out of bounds that aren't in the box and whisker plot. That's a nostalgic name, but that is out of like the interquartile range. Looking at this, I think it's fine. You would have to see again on a case per case basis, like, is this like a outlier significant to remove? Maybe these outliers are significant, so I don't want to remove them. In this case, I'm assuming that they are significant and I'm not going to remove them. I think it is okay to leave them here. It should be okay. Again, like if you do want to remove them, you can. It just depends on a case by case basis, but for this specific data frame, I'm gonna keep them. They look, if there's 1, 2, 3, 4, about 4 outliers, I'm gonna say that they are significant. If, for example, like you did wanna, let's say I wanna rerun this. Let's say I wanna like, let's take a look at our statistical. Here, I'm gonna do this. The way you can see if like you want to keep if these outliers would be significant or not, again, you can do df.describe and double check to see like if it is important. Like, do I want to keep it? Do I want not to? Also, as you can see, our standard deviation got a lot better from previous, which is really good. Ooh, there you go. But yeah, and looking at sepal width specifically, it actually falls within a range. I don't really see a problem that we have to remove it. So the values are all single digit. The maximum is 4.4, which is right over here. And I'm gonna assume that this outlier is significant. It still falls like within the range of normal values. So I'm gonna leave it and just remove like the crazy outliers. So I'm just gonna assume that they are significant. But now let's do some different kinds of visualization. So now that we removed null values, we've dropped the duplicates, we fixed the outliers, I want to see if there may be any relationship with any of the features. So again, yeah, depending on what you do, there's different kind of charts. As we just did, there's box plots, histograms, sorry. There's scatter plots. And the one we're going to work with right now is we're going to do a scatter plot to see if there is a correlation between sepal length and sepal width. All I'm going to do is df.plot. I'm going to do the kind of chart that I want. It's going to be a scatter plot. You can change this to histogram, box plot, whatever you want. On the axis, I want to do the sepal length, and on the y-axis, I want to do sepal width. Plot.show shows the plot. And so looking at these looking at this plot, can you guys see anything? Like, do you guys think there's like any sort of relationship with it? Ember. Oh, sorry, I keep forgetting to change the chat. Check the chat. So the indexes do change. For this case, it was just like each one was already assigned. So this is like, you can say that this is like the ID. So this ID, which is, an ID is a specific unique value to this specific observation. So that's why it wasn't 100. This is why it wasn't renumbered. Because this is the ID. This is a unique value only for this specific observation. So the indices itself did change. And the total rows changed because we drop rows. But this is like the ID of the quote unquote ID of the observation. Hopefully that made sense. Hopefully that answered it. Okay. So can anyone tell me, like, looking at this, is there any correlation? Yeah, it's hard. Thank you, Samin. It's hard to tell. Like, all the values are kind of scattered. Like, I'm not seeing a clear, like, positive or negative, like, correlation with it. So I just wanted to see, I was just curious to see if there was any relationship with it, but looking at this chart, I don't really see anything. But yeah. And now let's say I want to see how many values are in each class. So the way I would do this is, again, like before, I'm going to create a condition for this specific class. So for in this data frame, I want to use the class feature. And then I'm going to count each value, sorry, let me explain this. For each class, I want the total number of it. So like, hopefully this shows it better. I know I'm not explaining this too much. It's a little difficult for me to explain this, but for each class, I want the total number for that class. Hopefully that was a little bit better. But I just want to get the total per each class. So I'm going to do dot value counts for each class, and I'm going to set that as our condition, and then I'm going to plot that condition. And I want a bar chart for this one. And so we get this. So we can see, like, for this specific class, there's almost 50. For this one, this is a little bit less. For this one, this is a little bit less. So all in all, it looks good. There is something called a class imbalance, which I'm not going to get into in this workshop because it can get a bit complicated. But all that a class imbalance is, it means like if let's say there's only this class, the versicolor and the virginica, and let's say for this class we had 50 values, but for this one we had only 10. That is a class imbalance. It just means that there is a weird number, or like let's say in a credit card transaction, there's fraud and not fraud. Let's say for fraud, there's only 10 values, for example, and then for not fraud, there's 50 values. So that's an imbalance in our data, which we would have to fix. I'm not going to go into it here, but it is something that I'm going to do in a different workshop to explain how we can fix that. But there's also an error that can come from here, and that's why we do this visualization. But for here, we can see everything is good. So we can also do a pair plot, which shows all of the like all of the features on all the features. So it's gonna give us like all the graphs possible, basically. So we're gonna do SNS.pair plot, and our data is gonna be the data frame. And so this one can take a little longer to run because it's creating a bunch of plots. But here we can see every single like chart imaginable, basically. Here, let me expand it, sorry. So yeah, in relation with sepal length, and for example, sepal length, this, if you ever, I'm going to show you later. I'm going to show you in a bit, actually. It's going to be all ones in a correlation matrix. I'm going to explain that. But here you can just see all the relationships. Is there any relationships? Maybe. I mean, here over here, you can see petal length and petal width seem to have a relationship. Again, same over here, which is again petal length and petal width. And so we can keep that in mind. And yeah, so that was about an hour. Here, let me check the chat. Does anyone have any questions before I go a bit further? Okay, yeah, does anyone have any questions? And thank you for my associates for answering all the questions in the chat that I have not seen. Okay. Thank you, Caesar. Okay. Okay. I'm gonna go into a bit of something what is called feature engineering. All it is basically is, do I want to keep this column or do I want to remove this column? Is this feature relevant to my data? Or is this feature important to my data? If I'm like, when I'm making a machine learning model, is this going to be useful? So that's all it is, basically. Or you can like or in feature engineering, there's also something called one-hot encoding. So let's say for our classes, which is an object type, let's say the machine learning model has no clue like what this I can't even say it, Virginica or Setosa is. So let's say I want to change this into numerical values. Does anyone have any clue how I would do that? No, perfect. Because I'm going to explain it right now. The way I would do it is I would change it into zeros and ones. Sorry, I'm losing my voice. Assign IDs. Yeah, in a way, it is like assigning an ID, but basically it's going to be zeros and ones. So let's say I'm going to create 3 new features out of this one class feature. I'm going to create one feature called Iris Versicolor, Iris Virginica, and Iris Setosa. So I'm going to have 3 new features, and I'm going to remove class altogether, but I'm going to have an extra 1, 2, 3 features in each of those features for each single row. Okay, so let's go back up to our data so this is a little bit more visible. So for can't pronounce some of them, but it's okay. So for each of the new features I created, which is Setosa, Versicolor, and Virginica, I'm gonna decide, okay, so for our first row, we have Iris Setosa, right? So for Iris Versicolor, it's gonna be a 0. which means false, which means this is not iris versicolor. Then I'm gonna go check iris virginica. Is this iris virginica? No, it's not. So I'm gonna give this a 0, false. It's not iris virginica. And then the final new feature that we created was iris setosa. Is this iris setosa? Yes. So I'm gonna give this a value of 1 because true, it is iris setosa. Basically, you would do that for each single observation, and you would go through it and you would just change it. So it's kind of like turning into a code like 001, but it's each individual feature. And so like Virginica is going to be for versicolor, it's going to be 0, Virginica, it's going to be 1, and for Vertosa, it's going to be for Setosa, what I'm sorry guys, it's going to be 0. But hopefully you guys get the gist of it. And now I have numerical values. Now all of the data types are going to be numerical values, and it's going to be easy to work with. So that is another form of feature engineering that we can do. But sorry, I'm scrolling as fast as I can. But yeah, or you can just remove the feature altogether if it has no relevance at all. Yeah, it's also called dummy encoding. Perfect, yeah. There is a function specifically that you can use in, I believe it is Pandas, that has like, which is dummy encoding. It's also one-hot encoding. You can also do it manually. There's like, you can do it either or. But yeah, and then usually when you create a pair plot, you also want to see, is there any correlation with any of the other like features? Is there a correlation between two features? Sorry, my voice. Is there a correlation between any of the two other features? This is something called multicollinearity. Basically, if two features are correlated, it can't cause problems in the model where it's like, oh, like this is weird, like what is going on? You could drop one of the columns. In that case, you can drop one of the columns and be like, okay, like they are linear related. There's multicollinearity, and I don't want this to happen. So I'm gonna remove, for example, what is it? Petal width, because it is gonna cause a problem in our data set. It's gonna cause a problem when we're creating the machine learning model. So I don't want it. But yeah, it's also another like important step when you're doing data cleaning. It comes more, ignore my spelling, but it usually comes into play more for the machine learning models. It's easier to kind of identify multicollinearity after you run the model, and you can be like, oh, like, how does this affect this, and this? I will be doing this in another workshop so you guys can see it into play. It's a little hard to explain it without showing you, but hopefully, like, if it is something you guys are interested in, I would highly suggest like researching this. There are so many YouTube videos on feature engineering. Yeah. So having, as if I was saying, it's like having less similar features would help the model like train. But it would probably be easier to show you guys. I will be doing this in another workshop, so you guys can come check it out. But feature engineering is a really interesting topic. I would highly recommend that you guys watch some YouTube videos on it. I'm learning more about it every single time. But yeah, like it is really interesting. Excuse me for nerding out a bit, but yeah. One way we can also like check correlation instead of like just looking at this plot, because sometimes it's not always obvious. You can see it in a numerical format. You can do df.core, which is just correlation, and you can see like this, the one that I was referring to previously, if you guys remember, is just sepal length with sepal length. This has to be 1 because they're exactly the same. But you can see in like comparison with, for example, petal length and petal width, there's a high correlation between the two. That is like really like interesting. Like I would look into this if I was doing a machine learning model. Yeah, as Amina said in the chat, it causes overfitting. When you're doing machine learning model, there's something called overfitting and underfitting. All that means is when you are trying to apply that machine learning model onto a different data set, how is it how accurate is it in regard to predicting those new values? So for example, overfitting, it's doing too well. Like it is being like the values are too like how do I explain this? The values are too specific for they were too specific for the data set you were training on. So when you are trying to put it onto another model, it is not generalizing well. Like it is like not like it is not generalizing enough. Um it focuses too much on the training data. Yeah, basically. And then underfitting, it just means it's the training like it's not giving a it's not giving a good accuracy. So it's like on the data that you are specifically training it on. Overfitting is usually more of is a bigger problem. You kind of I would say I see it more often. But yeah, in terms of the underfitting, like it's not fitting the model like enough, if that makes sense. Hopefully I'm explaining it right. If one of my associates wants to give in the chat a bit of an explanation about what overfitting and underfitting is, that would be awesome. So hopefully we can I will delve into it in another workshop, but they can give you like also a gist if you guys have questions. But yeah, and then another way, if you want to see this in a more visual manner, other than the plots, you can do a heat map. You can do a heat map, which is just shows us the same information over here, just prettier. So df.core is the correlation that we were doing before. And then anout true just gives us the number in the cell. So let's say I was to remove this and rerun it. It's not going to give us the correlations that I saw before. So that's all that does, the anout. And yeah, that is yes, Anita, thank you so much. Overfitting knows too much and wouldn't be able to predict and be smart, basically. Yeah. Yeah, basically. But that is the end of the workshop. Yeah, that's the end of the workshop. Do you guys have any questions about anything that we've done before? I know the end was a bit more like confusing or I didn't explain it good enough, but please feel free to ask questions. I'm gonna stop sharing. Thank you, Afaz. Okay. I mean, if and no one has any other questions, you guys please, if they pop up later on, feel free to message us in the Discord. I'm always checking Discord. Most of us are checking Discord. But before you go, if you guys did come in late, if you guys could check the sign-in sheet. Check the sign-in sheet. Yes, English, amazing. If you could sign in the sign-in sheet and fill it out, that would be awesome. Hopefully you guys enjoyed the workshop. I will be doing a logistical and linear regression workshop coming up soon, so be on the lookout for that. That's going to be somewhere in November. It is going to be yeah, mid-November, I want to say. But you are basically everything that we just did is what you want is what you're going to do before that. Like what we do before that, but we're going to work with clean data already in that workshop. But this is like a really important topic. If you guys are interested in data science, it's important to understand it and like figure out like just use it. I'm gonna stop talking, but thank you so much. Thank you everyone for coming and for listening. Hopefully this was interesting, and I will see you guys all in the next workshop. Thank you everyone for coming. Please don't forget to sign in. I'm gonna stop the recording.